Now, architectures shall support building products and maintaining them over time. And that's why you definitely need architecture if you do real-life programming, apart from simple expressions and hello world programs. Now, what is architecture made up? So what kind of things do you need to do if you want to practice architecture? You definitely need to care about requirements. So what kind of product do you need to build? You need to care about designing your system, how to structure your system, how to build your system. You need to communicate with your team members because you are not working alone, except from simple expressions and hello world. And you need to check if you're done, if the product is good enough. And you do this in iterations. If I had 2 or 3 days, I would explain all these stuff to you, but they gave me only a few minutes, so I just pick out a tiny example of designing a system. Designing systems is really simple. You need to build a new feature. You all know what a feature is. Some abstract, your clients want something new. A new product, a new tariff, something new. And now what you have to do is decide in which of the components of your system, component 1, 2, 3, or whatever, shall you implement that new feature? Very simple question. You already have some components. You might use one of these components for your new feature, or you create a new component. It's a very simple day-to-day question. And now, it's very obvious the best solution for the team would be component N. You with me? The best solution for the team. The best solution for performance is component 1. And a new component would be the best for security. And that's what I mean by architecture is the art of compromise. What do you do now? You need to give the team a bit, you need to care for performance, you need to care also for security. And again, you need to take these compromises. So you need to decide how much performance, how much security, and so on. And this is a very difficult thing. It's a very difficult discipline, but it's absolutely needed and required. You can do that methodically. Many ideas have been brought to practice, like domain-driven design, like quality-driven design, like architectural views, and so on. It's methods that help you design your system. And there is a lot of basic principles that have to be applied, like coupling, cohesion, and so on. Applying these principles will definitely make your systems better, but it's not enough. You need to combine those. As I said, this is a difficult discipline because one more reason is you have to talk to a lot of different people in it. And a good friend of mine, Gregor Hoppe, called this the architecture elevator. From the business strategy down to the engine room, you have to talk to people. And these people are really, really different. Because with the guy on the left, you need to talk a bit differently than to the developer who is sitting in front of the machine and doing programming. Hopefully not in Perl. Now, this is a very short take on architecture. Architecture definitely should be a developer skill. It's not just the single person sitting in the next room, but it's a developer skill for everybody developing software. And my proposal is to split the architecture role within the team. So make a few people in the team responsible for the architecture. Maybe not everybody, but many developers should know about that. As I said, it's difficult. Start small. You need to practice architecture, probably do some small open source things, improve the architecture in there. And my take is you should learn architecture. I discussed with Victor, there is possibilities in our industry to learn about requirements engineering, to learn about project management and Scrum and Agile methodologies, there is options to learn about testing, and there are many options to learn about architecture. I put some flyers out there. I don't want to sell myself teaching you architecture, but I want to make you a bit more aware that architecture can be learned and should be learned. We have currently in Europe around 20,000 certified architects that did that completed some learning path for this difficult discipline of software architecture. I tried to come up with a easy to remember URL, bit.ly learn-architecture. Look for yourself if that's something for you. Thank you very much. So I invite the next keynote speaker, or maybe Victor is going to invite the next keynote speaker.
I'll self-invite myself.
Okay.
Let me do this.
Yeah.
Our job is quite frequently to deal with architects because they are one of two positions who are integrating our tools and getting them steady in their infrastructures. Why do we even want to talk about lift and shifts on the Cloud Architecture Conference? Because it's the last resort when the efforts of your cloud modernization don't work. And this is where you learn the most. So it's going to be a little brain gym at 10 a.m. for those who didn't have enough coffee. I would really appreciate the consistency of the microphone. Why would someone in the sober mind want to lift and shift an application to the cloud? The obvious answer is drop in capital expenses, potential drop in salaries to maintain hardware, potential drop in data center infrastructure, operational load, yada, 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 yada. The other reason is we want to outsource the risks. We want somebody else's head to feel headache for a lot of operational concerns. Easier technology, and what's important, understandable operational expenses. It's just linear. You provision compute, you pay for compute. But what are you actually lifting and shifting when you put all that nice stuff into cloud the way it is? You are shifting architectural decisions. And what worked in your data center doesn't necessarily work optimally in cloud. I hope most of this room understands that really well. So, why does that even happen? Because there is always somebody whom you are making happy with compromise of lift and shift. Many engineers call these people the business. For the last 12 years, I've been the business to whom engineers have sold their solutions and who approved budgets and the way to go. Who's the business? The business is a victim of Goodhart's law. Premature optimization towards weird metrics. They have KPIs, OKRs, monitoring dashboards, accounting. They live in the world of numbers. They have no clue what happens in reality. They are so much in pain of so many things happening at the same time and so many things on fire that their brain naturally, that's the result of evolution, it gets risk averse. It doesn't want more risks. It doesn't want more ununderstandable stuff. What does this brain miss? It's not so cheap. Many of you might know, orchestrating lift and shift migrations are expensive. Custom applications are very expensive to migrate to cloud without re-engineering them. Then you over-provision compute power just because there is no dynamic compute management depending on demand. Hidden risks. You move the security assumptions towards the cloud. You move the reliability assumptions towards the cloud, which are completely irrelevant. You spread yourself thin over top 6 layers of OSI model, where you should care for the top 3. You duplicate the effort which cloud provider already does, like maintaining and patching operating systems and stuff. Why these things are not really understood by the management, by the business? In some cases, the business is overloaded. It happens. But what if not? Typically, because the architectural decisions of let's redo it properly are poorly articulated and poorly communicated. Modern engineers speak more about that's great stuff, Cisco uses that. This stuff is going to make our company awesome. This stuff will make it easier to hire young engineers interested in technology. The manager responsible for the decision doesn't care. The manager cares for the money, for the risks, for the operational agility, for things which have nothing to do with technology. Technology is just a hammer to a nail. Let's see when the lift and shifting is actually good. It's good when the cost and risk of re-engineering exceeds perceived benefits. What's important? Exceeds within some foreseeable future. If you are re-engineering and it will become profitable within 10 years, and the planning period of your business is a year, you're in trouble. Nobody's going to get it. The other thing is some applications are really hard to lift and shift. One, big server architectures, cloud edge integration with physical devices in almost real time. Think SCADA. Try to put SCADA into cloud. Sometimes it is easier to lift and shift or to build from scratch. If it's not the case, and the business isn't, as I write here, a bunch of tired lunatics, your job as engineers who strive to become cloud architects and in future proper software architects, solutions architects, or whatever is, learn to bloody speak. And I've got a story to finish this. I come from the security industry. We obviously have a very heavy opinions on many things, just due to the nature of talent that comes to this industry. So one of the prominent security researchers who worked for Google, who was involved in inventing automated fuzzing, yada, 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 like celebrity in our business, got tired of security. Imagine what he did. He started the company who does one thing. It chases ineffective cloud solutions provisioned and envisioned by young, talented architects. He comes to their bosses, to the business, and says, I'm going to optimize your cloud expenses for, say, X amount of money. I'm not going to charge you for my services. I'm going to get a premium out of the money I've cut from the expenses you currently got, just by changing the architectural design, just by suggesting a few improvements in the data flow, and so on, so on, so on. Security is extremely profitable discipline. If you're a security engineer, you earn good money. This guy says, I'm not coming back to a security industry because fixing faults of other cloud architects turned out to be sufficiently profitable and fun business that he intends to spend last few decades of his career doing exactly that. I'd like to hope that his work touches only results of work of other architects, not people in this room, because I would like to hope that what you guys do will not be profitable for vultures who seek other people's mistakes. Thank you. I think we need the next one.
На самом деле я очень люблю эту конференцию. В предыдущем году мы ее запускали замечательно. В прошлом году было много людей, в этом году еще больше людей. Я вот, смотря на предыдущих спикеров, подготовил совершенно не тот вообще спич на keynote, как они. Я вообще на русском языке готовился. Вот, и слайды не того формата, так что вы уж извините, я тут о жизни буду общаться. Так уж сложилось, я возглавляю архитектурную экспертизу сейчас в компании, и я стыкаюсь каждый день с людьми, которые либо уже являются архитектами, либо пытаются стать архитектами, либо когда-то были архитектами, то есть на стороне клиентов. И поменяю немножко тему. Большинство из вас, скорее всего, видели в Фейсбуке сейчас рекламу. Сейчас всем айтишникам предлагают куда-то инвестировать, то есть достичь успешного успеха, там, вложиться по 10, 20, там, 100-500% в год. То есть нам говорят, будь мужиком, вложи деньги. Да? Это замечательно. Но дело в том, что наше IT, даже если посмотреть на статистику, в худшем случае дает 30% роста каждый год. То есть мы с вами, друзья, каждый год, того не ведая, растем процентов на 30. У наших компаний всех там стоят цели расти еще больше. Ключевые компании там дают плюс 40-50% роста в год. Вывод. Нам надо инвестировать в себя. И это нам даст больше, нежели дают в банках, нежели дают всякие блокчейны, биткоины и так далее, в среднем по палате. И это надежно. То есть инвестиция в себя дает намного больше, и плюс это остается с вами. Это с вами никуда не уйдет с инфляцией. Вы всегда для себя останетесь лучше, нежели были вчера. И это является ключевым месседжем моего сегодняшнего киноута. Для того, чтобы мы с вами, друзья, айтишники, смогли быть лучше завтра, нежели сегодня, мы должны понимать, чем мы вообще занимаемся как айтишники. Есть замечательное такое кольцо, которое показывает жизненный цикл IT. Я опять-таки опираюсь на консалтинг, потому что для продукта здесь чуть-чуть отличаются некоторые блоки. Вы уж меня извините, я человек с консалтинга. Но если каждый из вас после моего сегодняшнего небольшого совершенно доклада выйдет с мыслью, что вам чего-то не хватает, глядя на вот этот замечательный круг, я достиг своего маленького успеха конкретно сегодня. Я кого-то, можно так сказать, укусил идеей выучить что-то новое. Мы, как айтишники, начинаем с той или иной точки. Кто-то начинает рисовать дизайн, занимается UX, кто-то начинает писать код, кто-то занимается администрированием, кто-то еще что-то делает, кто-то, не дай Боже, менеджер начинает. Но в любом случае это отдельный кусочек общего цикла. И это важно понимать. Только тогда, когда мы, каждый из нас, понимаем полный цикл, можем на него влиять, на отдельно взятые блоки, мы увеличиваем свою ценность. Наша инвестиция приносит нам плоды. Если посмотреть на адекватное понимание слова enterprise, не то понимание, которое есть в нашем замечательном итальянском IT, это все-таки не банки, это не какие-то древние вещи, это не костыли, это все-таки объединение бизнесового и объединение технологического на основании того, что у вас есть, на основании команд, которые у вас есть, на основании технологий, которые у вас есть, подходы, работы с аналитикой, со сбором информации, всего этого. И по сути дела, enterprise-ная архитектура является ключевой причиной наличия вообще в принципе фреймворков, подходов к архитектуре в частности. Когда мы это осознаем, а не ведемся на описание того, что описано в вакансиях, условно там ищем enterprise-специалиста куда-то в банк, когда мы улавливаем суть, а не то, что нам предлагает рекрутер, мы лично для себя повышаем, скажем так, понимание того, что вообще работает как в IT. Мы лично свою ценность повышаем как специалисты. Вам это важно понять. Допустим, есть бизнес-архитекты, есть технологические архитекты, и только вместе, объединяя бизнес и объединяя технологии, мы можем построить действительно жизнеспособное решение. Как в маленьких продуктах, так и в больших продуктах. Специалисты, которые умеют это объединить, сейчас вообще называются диджитал-архитекты. Да? У нас сегодня будет выступать несколько людей, которые все в тайтле имеют диджитал приставочку. Пожалуйста, посетите, послушайте, чем люди занимаются, в чем секрет их магии, каким образом они объединяют технологии и бизнес. Небольшой, так сказать, спойлер, обычно это достигается методом привлечения отдельно взятых специалистов. То есть технолог может ходить и брать к себе каких-то аналитиков, брать UX-еров, брать кого угодно. И наоборот, бизнес-архитектор идет за технологиями. Только методом объединения усилий можно достичь покрытия полностью цикла жизненного продукта. Если посмотреть на то, что мы имеем сейчас на маркете, если посмотреть на вас, посмотреть на меня, то мы на отдельных этапах нашей карьеры покрываем то или иное. Мы либо вдаемся, как говорится, hard skills, то есть мы изучаем что-то до бесконечности, углубляемся. Если мы следуем за хайпом, мы становимся клауд-архитектами, DevOps-архитектами, Big Data-архитектами. Это все замечательно. Но если посмотреть на это глобально, то надо объединять в себе несколько экспертиз. Или, если мы этого не можем сделать сами, а мы не можем сделать сами, потому что у нас время ограничено, мы хотим спать, мы хотим кушать, гулять и так далее, мы должны знать, кто нам может помочь. Мы должны опираться на экспертизу своих друзей, знакомых, коллег и так далее. Только вместе мы можем покрыть полностью то, что называется архитектурой. Мы можем строить стратегию, потому что знание отдельных направлений делает нас замечательными тактиками. Мы можем быть боженьками, допустим, в Big Data, но мы не можем сделать стратегию построения продукта, Big Data продукта, если мы не ведем коммуникацию с остальными. Фреймворки. Так или иначе, мы, приходя в IT, начинаем с чего-то. Допустим, мы начинаем писать код. На каком-то этапе мы находим для себя сайты с паттернами программирования, понимаем, что все давно изучено, все давно описано, и мы не можем изобрести новый тип шины данных, допустим, или новый тип коннектора. Все так или иначе уже придумано до нас. Что мы можем сделать? Мы можем освоить идеально, узнать то, что мы делаем, стать доменным экспертом. И начиная с этого замечательного фундамента, мы можем строить дом сверху. Дом состоит из множества аспектов. Вот как любит приводить Максим Безуглый пример. Если вы специалист по построению канализации, ну там не так было, конечно, пример, но тем не менее, канализация только часть дома, вы можете идеально построить. Но если вы не изучите, допустим, систему построения канализации, а будете до бесконечности делать маленькие удобные горшки, это, конечно, закроет потребности вашего маленького дома, но не будет все-таки работать на большом скейле. Кстати, здесь опять-таки отсылка к микросервисам, которые являются идеальными такими маленькими горшочками. В чем суть? Фреймворки архитектурные, да в принципе, как и все фреймворки, они призваны покрыть много, покрыть все то, что необходимо для жизнеспособности продукта. Вот я привожу опять-таки наш пример, да, то есть мы на данный момент удосужились построить вот такой вот базовый фреймворк, что мы вкладываем в архитектуру. На основании ТОГов, на основании Захмана, на основании SEI, на основании еще кучи всего. Сейчас каждая уважающая себя большая компания имеет свой какой-то фреймворк. Я имею в виду глобальные компании, то есть не украинские, а глобальные. Можно уже много где чего подчеркнуть. Вопрос именно в том, что они так или иначе пересекаются. Есть ключевые принципы, которые свойственны всем фреймворкам. Вы можете быть сертифицированным супер-мега-архитектом по какому-то направлению, и вы все равно будете опираться на те же самые архитектурные драйверы, на те же самые принципы, на те же самые какие-то технологические домены. Все будет зависеть только от степени старости, скажем так, той или иной документации. Если вы читаете книжку, созданную во времена, допустим, монолитов, у вас будет одна терминология. В современную книжку у вас будет другая терминология. Но принципы, стоящие за этим, одни и те же. Принципы архитектурные, стоящие за монолитом и за микросервисами, отличаются только названиями. Если вы посмотрите логически на то, из чего это состоит, для вас все будет понятно. Поэтому главное понимать, с каких блоков в принципе состоит архитектура. Архитектура — это стратегия. Она может состоять из кучи тактических решений, технологических, других вариантов, которые там входят специфично в ваш продукт. Но в конечном итоге стратегия понятна и выстраивается как военное искусство. Уже давно известны основные варианты развития событий. Архитекторы обязаны понимать это все. Не обязаны знать все, но должны понимать, из каких блоков состоит. Мы должны понимать, что есть понятие soft skills, которые входят в нашу экспертизу. Есть понятие hard skills. Мы можем либо сами знать, либо опираться на чью-то экспертизу. Но мы должны понимать, что этот блок так или иначе присутствует. Пожалуйста, посмотрите на эту картинку, сфотографируйте, определите для себя, чего лично вам не хватает, каких знаний вам не хватает. И завтра, послезавтра, через год, через два вы будете круче, нежели были до этого. Если вы все-таки прислушаетесь к моим словам и будете понимать, из чего состоит наше замечательное IT. Это не только отдельные специфичные направления, в которых вы, я надеюсь, достигли уже потолка, достигли самого успешного успеха, который только есть. Мы так или иначе постоянно должны развиваться. Если мы не развиваемся, все. Очень просто показано, каким образом каждый из нас должен циклично снова и снова развивать нашу экспертизу. Здесь вместо слова architecture можно добавить любое. Вы можете сюда добавить, не знаю, умение танцевать. То есть вы сначала подключаетесь к какой-то программе, где вы можете узнать, как это можно изучить. Это может быть self-made программа, это может быть что-то существующее в большой компании, может быть что-то существующее на маркете. После этого вы начинаете улучшать свои навыки методом тренировок. Постоянно, постоянно, постоянно вы к чему-то подключаетесь, просите, чтобы вас взяли с собой. В итоге вы переходите, по сути дела, в постоянную практику, где на основании этой практики и постоянного жизненного опыта, допустим, вас берут постоянно пилить новые приложения, или, допустим, вы постоянно создаете свои новые продукты. Вы каждый новый продукт делаете лучше. Это то, что там все с бизнес-стримов рассказывают. Чем больше было фейлов, тем лучше следующий результат. Вы снова пробуете, и после этого желательно провести оценку ваших навыков. В некоторых случаях уместно провести сертификацию. Опять-таки, сертификация должен быть один из способов, это не должна быть самоцель. От того, что вы станете, допустим, +1 Google архитектором или +1 AWS архитектор, а это потом еще экспарится через несколько лет, вам от этого легче не станет. Вы должны понимать, улавливать принципы. От того, что вы заучите ответы на какие-то вопросы в AWS сертификации, вам от этого легче не станет, и вы не станете стратегически более дорогим специалистом. Но тактически станете, плюс 500 вам дадут. Учтите это. Мы постоянно должны по этому циклу бегать, и в конечном итоге мы увеличим свою ценность, мы инвестируем в себя. Уйдите, пожалуйста, после моего кейноута с осознанием этой мысли. В себя нужно инвестировать. Окей? Окей. На этом все. Если кто-то очень захочет, можете меня добавить в LinkedIn. Это QR-код. Телефон наводите, оно работает. Я отвечаю за архитектуру, отвечаю за технологии, отвечаю за много-много всего. Спасибо.
I love the first keynote, but I would like to just make a statement. Functional programmers don't suffer that problem, so maybe we should have more functional programmers as well. So I would like to, to chat with Ger later on his thought on that. Okay, so what am I going to talk in the next 10 minutes, and who am I? So I'm Angelo Corsaro, CTO at EdiLink. We are a company that works in general on everything that has to do with, let's say, industrial application and anything that typically you find out there in things that moves from tractors to airplanes and so on and so forth. I've been working on fog computing since the very beginning. In fact, I was one of the guys, along with Flavio Bonomi, maybe some of you have heard his name in this context, that actually did the initial work on fog computing. And as a team, we are, I think, the team that made the first fog platform implementation that is really addressing this kind of challenge bottom up. So what I'm going to do in the next 10 minutes is trying to explain you where we are currently looking at, but where actually we should be looking, okay? And what are the challenges in order to get there, and I think why we should get there. For those interested in this, there will be a full 45 minutes presentation on track B, I believe, on fog computing. Okay, so let's get started with what are most of us, or most of you doing today. So most of you, and it's not a surprise, are into some form of cloud computing, either because you are doing, you are leveraging cloud to reduce your capex and moving to opex, or because maybe you are a company working in the emerging IoT market and you've adopted a cloud-centric architecture. So cloud-centric architecture are all about, some people call them the octopus architecture. So you have the cloud that has plenty of resources, where the real brain, the computation, and everything converge, and then you keep devices on the periphery typically as relatively non-intelligent entities, although many of those devices have indeed non-trivial computational capabilities. There are several challenges with this model. However you look at it, there are some benefits, but there are indeed some major challenges. So let's try to look at some of the benefits. The benefit is that the technology ecosystem is very rich, especially if you look at the technology that were developed in the context of general cloud computing. And the first wave of cloud computing was used mostly for IT offloading, okay? Those can be reused by emerging market in IoT and, as we will see in MEC, that are cloud-centric. So that's one of the big advantage. So if you look at management, provisioning, but if you look also at storage technology, network virtualization, everything is already there, so that's quite good. On the other hand, if you look at the flip coin, pushing data to the cloud has impact with respect to energy consumption, and that's sometimes a big issue in some application, with respect to throughput, with respect to confidentiality, and with respect to monetization, because all of a sudden it makes it much, much harder to monetize data for the data owner. Okay, so that's quite important. But if you look just at the challenges induced by, let's say, throughput or perhaps energy, and the fact that sometimes you would really want to have computation as close as possible to where the data is being produced, then there was an idea that says, hey, how about actually trying to move something that looks like a data center? It's like some people call it cloudlet or edge data center. That is a little bit less resourceful than what you have in a traditional either private or public cloud, but happen to be a little bit closer to where the data is produced. Okay, so that's the idea behind edge computing. And well, I will go in much more detail of why the entire idea of edge computing actually doesn't make sense for a very simple reason. I will show you a few examples in which, in the 45-minute talk, in which actually you can't draw the edge. Okay, so I'll give you a very quick hint. So if you look at an industrial automation application that in a couple of years will be leveraging 5G. Where is the edge? Is it your in-factory infrastructure, or is it the MEC server on the side of the telco operator, or perhaps some MEC server from yet another third party? So the basic idea of drawing an edge falls short very, very quickly. But anyway, this is where I know many are looking today. The environment is kind of similar to what you would find in a cloud, in the sense that it's still pretty resourceful, quite homogeneous, and quite a few of initiatives related to the cloud native, okay, are actually applicable to this environment of edge computing. And you see that the edge becomes, in a way, an extension of the cloud, okay? But the modus operandi, as we say in Latin, becomes roughly the same. But so if we look again at the landscape, most of the technology can be reused. There is some innovation in the context of cloud native, but it's more or less a variation of what we already know how to do. So the real challenge and what we really should be able to do, and what is really required for a large class of emerging systems, actually is to be able not to segregate something that we call cloud, some other infrastructure that we call edge, and the rest of the things. But to realize that all of those, whether it's a powerful server sitting in a data center, let it be Amazon data center or company X, Y, or Z data center, some edge infrastructure, which might be, once again, managed by ourselves, by a telco operator, and that will become the norm with 5G, or perhaps yet another company. There will be, with 5G coming, an entire new business model of private company providing this kind of infrastructure as close as possible to where data is produced. And then actually the device. And when I see device, here you see boards, but I'm talking about cars, about tractors, or perhaps even a device that you have at home, okay? So if you look at this, all of a sudden, the reality is that we have a pool of resources that is geo-distributed from the cloud down to potentially our home. And several applications will have the need to manage and provision all of them in a very uniform manner. Okay, so how do we do that? I mean, that's a far more interesting problem, but it's rather challenging. Why? Resources are very heterogeneous. So they can go from high-end server in the cloud to STM32 or even less that I might have in some application. Okay, we are working with some telco operator that are building solution on what they call nanocomputer that they see soon in the house of the people, and they want to be able to provision, monitor and manage those things essentially from anywhere, from your house as well as from potentially their operation center, okay? You might have to do with OT systems in which you have to deal with I/O. So if you look at the cloud world doesn't know what is I/O. If I say GPIO or let's say a TSN or CAN bus, most of the cloud people have no clue what it is, okay? But it's highly relevant in a factory floor. And once again, if I need to provision and manage an application end-to-end, if I need to deploy, for instance, my soft PLC, I need to deploy it, for instance, on a server that is connected to a TSN, right? And that provides the right kind of a network connection. So all of those challenges and those, let's say, peculiarities that are specific to the domain as we look at it in an holistic manner are just not addressed by the current technologies. The current technology for management, but the problem goes well beyond. And in fact, there are really three classes of problems that need to be solved in order to make fog computing, and as such, this, the ability of managing end-to-end resources, regardless of where they are, pretty much from anywhere. The first problem we have to solve is that today, in reality, there isn't a single technology that you can use to seamlessly exchange data from a server that is sitting anywhere to potentially a sensor or a nanocomputer that is connected perhaps through a low-power network. Because if you try to do that, it's an integration nightmare, and you have to put together at least 2 or 3 different protocols. That makes the problem very hard. Think about creating a private and secure network end-to-end. So very, very hard. I mean, it's possible, but it's just a mess. Okay, it's bricolage, as we say in French. The second problem that we need to solve is about storage. So if you look at the storage solution, most of the, well, I would say all the storage solutions today were designed with data center in mind. So the key problem of storage solution today is about sharding. So I assume that they have a huge set of data that needs to be scaled out across a bunch of servers that typically sits in the same data center. People in the cloud are already having huge problems with respect to data lake integration, because very often many of these technologies require you to duplicate the data, which is not possible. But if you look at the environment I was describing, actually, all of a sudden, we need to maintain data as much as possible locally, but still, we want to be able to provide global access to this data to those that have the rights to do so. So this kind of technology will have 2 benefits. Number 1, data remains closer to where the computation is performed, okay? Number 2, as I am the owner of the data, all of a sudden I decide who can access the data, and I have choices on the monetization of my data. So all of a sudden the values goes from the GAFAM to me, who is the owner of the data. Okay, so that's something to which we are very sensible. And if you look at the impact on the network, actually, this kind of architecture, although are harder to build, they are far more, let's say, efficient with respect to network utilization. And you can use this kind of technology all of a sudden to also avoid some of the problems that exist today. So I have friends that work in home automation, and one of the problems that some of the mainstream solutions have is that you lose your internet connection and nothing works anymore because you are completely dependent on the cloud. So those are some of the challenges that needs to be resolved. And the last point is that what we need to address also, once we have the ability of establishing communication end-to-end in this highly heterogeneous world, having an infrastructure that allows us to store data where it makes sense, but then address it as if it was at our fingertips, okay? Because you need this uniform, location transparent and uniform access to data regardless of where it's stored. Then at that point, we can leverage this technology to really build a provisioning and management infrastructure, that's what we call a fog platform, that allow us to provision and monitor anything from the data center to potentially the microcontroller. Try to understand that doing that doesn't mean that all of a sudden this infrastructure has to be able to deal with things like containers, VM, but that's typical for cloud, but also unikernels, because of, in some cases, security and footprint constraint, as well as potentially binary applications, okay? So we have done quite a bit of work of isolation of binary applications as well, because in some instances, if I have to do an update into a remote site over a relatively constrained network, I just cannot afford typically to send a container. A container is way too big if I have to send it on a few hundred kilobit per second link, okay? That just doesn't get through. The other aspect is network management, end-to-end network virtualization, as well as the ability of supporting weird networks like CAN bus and TSN. Not sure if any of you is familiar with TSN. That's a very important new technology. It's an extension of Ethernet. So at the MAC level, it's similar. There are physical layers exactly the same. MAC level, there are few extensions. But it's the holy grail of real-time application, because in a couple of years, they will be able to do real-time and non-real-time on the same network that does just Ethernet cabling. So for industrial automation and automotive, it's quite important. But you need to be able to understand, provision, and properly virtualize this network, and that's what this kind of platform have to do. So I think I have 3 more minutes left, okay? So I want to give you some pointer if you want to learn more what the state of the art in terms of R&D and development and some of our open source technology that are already available to solve this problem, so that if you're interested, you can dig more. So the first one, Zeno. Zeno is an emerging protocol that provides you with this end-to-end abstraction. It is NDN protocol, so for those of you that are familiar with some of the next generation internet initiative, NDN stands for Name Data Networking Protocol, are protocol that can go on top of layer 2, so they don't require IP, which is essential if you want to be efficient over low-PAN, either personal or one-area network. And they are not host-centric, because if you think about IP, IP is host-centric, but most of our applications care about data, not about host. Okay, so these protocols are data-centric. You address data, you don't address the host. In terms of the other interesting things is that it provides you the key abstraction required by many applications. So you have diffusion by publisher subscription. You have support for devices that go on sleep, so they can subscribe, the infrastructure get the data as close as possible to them, and whenever they wake up, they can either pull or the data is pushed to them, and you also have support for distributed queries, which is quite useful when you have a large set of data. API available in most programming languages, and I think the most important thing is that this protocol can fit into 300 bytes. So you can put it very easily on an Atmel microcontroller, and if you look at the throughput, we have numbers. It's actually far more performing than things like NATS and anything else that is out there. In terms of distributed storage, there is YAX. That's, again, a distributed storage plugin for Zeno. So Zeno has all the protocol mechanisms that makes it easy to build and resolve distributed data. And as I will describe in my presentation that will be on StreamB, there is, in fact, an open source project called FogOS that has already been used in lots of deployment in Europe, well, deployment that you would call FogOS deployment, that provides a platform precisely to address the provisioning and the operation in this environment. So thank you very much, and I wish you a very good conference.